Hello, everybody, and today I'm going to be talking to you about autonomous vehicles in my science fair project. Yep, you heard that right. We're talking autonomous vehicles, such as mine right here. Now, what are autonomous vehicles, you may ask? Autonomous vehicles are vehicles that do not require the need for human intervention. They don't need someone to ride them or to control them. They run by themselves and they use sensors. Now, there's a lot of companies that are making autonomous vehicles, such as Tesla, Volvo, and even Google is making some headway into the autonomous vehicle world. Now, there's a lot of debate in the self-driving world of what kinds of sensors to use. Tesla, on one side, wants to always use vision-based camera sensors. Other companies use what we call LiDAR, which stands for light detection and ranging. And what that does is it uses a laser that's constantly spinning on the front of the top of the car and is capturing depth perception at an extremely fast refresh rate, which is pretty interesting. Now, there's also companies that also trying to use GPS, but I don't see how that's really good because it can't adapt to the live environment of the car in the first place. However, I'm going to be showing you today about what my car uses. My car uses what we call IR sensors. Now, if you remember from science class what IR stands for, it stands for infrared wavelength. These cars use these types of sensors, which consists mainly of an emitter diode, which emits infrared light, and a receiver diode, which receives infrared light. This car uses 5 IR sensors. 1, 2, 3, 4, and 5. Now, what we're gonna do is I'm gonna explain to you the parts of the car quickly, okay? So, the first part of the car I need to mention is the Arduino microcontroller. Now, this is essentially the brain of the car, and what it does is it's like it's a brain. It receives input and acts accordingly and gives an output. Under here, you might not be able to see it, but inside of the car, there's another board, and that thing is called the motor driver module. Ooh, big name, right? And what it is, it's basically, I would compare it to the muscle of the car. It gives the electricity that the car needs to the 4 electric motors. The additional parts are the voltage meter over here, some pin wires to connect each other, and this battery box, which I have the batteries for right over here. Let's get that. See if I connect it right here. These are not your normal batteries here, not AA or AAA. These are a different type of battery. They're lithium batteries that are rechargeable and help give a certain amount of voltage to the car to make it run stable. Now, what we're gonna do is I'm gonna show you how this works in a few seconds. Now, what I programmed this car to do is that when the middle sensor sees black and when these 4 sensors on the outside sees white, or in this case, since I'm using cardboard, it's gonna be brown, it will go forward. Okay, so let me show you an example. So we're here, we got this first tape right here and it's black. These guys are gonna see cardboard if I push it here. And if it sees like that, then the car will keep on going forward. But as you can see, it won't happen forever because now we have this sensor seeing black. So whenever any of these sensors sense black, I've programmed it so that when it happens, it will turn accordingly so that it maintains white on the 4 outside sensors, but black only on the middle. So let me show you a live demonstration. On your marks, get set, go. And as you can see it turning, go forward, go forward, turn. Oh yeah, yep, just like that, boy, yep. And as you can see, it just keeps on looping forever and ever until I turn it off. My project was to see whether or not the amount of IR sensors on the car affected its accuracy, which you can see on my problem right here. So, does the number of infrared sensors on an autonomous line following robot affect its accuracy? And my hypothesis was that yes, it would. However, as I did the experiments and I tried different amount of IR sensors, I don't have time to get into the details. But my hypothesis was both correct and incorrect at the same time. You see, my car was able to finish the track with all 5 sensors that were active. However, when I removed one sensor, the car was not able to turn. It didn't see the turn and just went straight on. However, when I did the car with only 3 sensors, it worked. It actually went one time across the track. Some other times it didn't fully complete the track, but it still once completed the entire track. But when I put it to 2 IR sensors and to only 1 IR sensor enabled, the car barely worked at all, just like the group with only 4 IR sensors. So I came to the conclusion that the amount of IR sensors is all very important, but there's also something very important that I missed, and that is the position of the IR sensors. You can have all of the IR sensors you want, but the placement is also key when creating robots or autonomous vehicles, such as these. So when making a robot, don't just say how many parts can I just stick on there and just put on the car or put on the robot. You need to also carefully consider the positioning of the IR sensors. Now, as we close out today, I want to recommend this car to anyone who likes to build stuff, because this is really, really, really fun to play with. Although it took a lot of time and a lot of effort, it's worth it when you can make it run by itself. So get yourself one of these and vroom vroom and see where this car can lead you into the future.